Hi, my name is Zhao. I'm a PhD student at Vanderbilt University. Today, I'm happy to present our work evaluating augmented reality landmark keys and frame of reference displays with virtual reality. Imagine a future where sleek, lightweight air glasses are part of our everyday wardrobe. We wear them all day, and we navigate in the city using these air glasses. How should we design them to assist navigation? Our current study explores the impact of ARQ in design decisions on navigation systems. In particular, we are interested in how AR aids could enhance spatial learning, which has been shown to be hindered by current smartphone turn-by-turn navigation systems. First, we consider what a more effective way is of displaying navigation instructions in AR. Specifically, we investigated two frames of reference for displaying information. Cues can be displayed screen fixed, fixing to the user's view. Cues can also be displayed word fixed, which presents cues fixing to physical locations. Although some previous research highlights the advantages of word fixed design, it was not inherently better than screen fixed design. Researchers suggest considering the context of use and information to display. Here, in the context of pedestrian navigation, we hypothesize that the word-based design will result in better spatial learning, given the ancillary cues should allow for more natural and intuitive interaction with the environment, eliminating the need for additional spatial transformations of cues. Second, we consider whether denoting landmarks with AR cues is helpful. Current navigation systems communicate navigation information by displaying turning actions at decision points that refers to streets and distances. However, studies find in reality, when people provide directions to others, they often prefer landmarks and crucial decision points, and incorporating landmark cues into navigation systems in walking and driving have shown the benefit for improving spatial learning. So we compared direction without landmark information and direction with landmark information in our experiment. We aim at validating the benefit of adding landmark cues in navigation systems and further exploring how to better anchor them in 3D AR design space to guide users' attention for better spatial learning. We predicted that spatial learning will be enhanced when cueing landmarks explicitly. In addition, as we know there are large differences in navigation ability among individuals, so we included self-reported spatial navigation ability measured by the Santa Barbara Sense of Direction Skill Questionnaire as a potential correlate with the wayfinding performance. We also try to balance the gender of participants in each condition to alleviate any conflicts it might have on the manipulations of cue design. We did our study by using the mixed reality simulation method to emulate an AR display in virtual urban environment. This provides us with rigorous control over the experimental setting, and we are not hindered by limitations of current AR HMDs, such as tracking instability over long distances. We designed a 2x2 between subjects experiment to investigate the effects of frame of reference and information type and any interactions between them. In the first screen fixed without landmark condition, an AR arrow cue along with remaining distance to the next decision points in text was used. The screen fixed cues are rendered at 1.3 meters in front of the camera in the lower half of the field of view by following previous design recommendations to provide more comfort for users' eyes and eyes. This video shows what people can see through the left eye. In the second screen fixed with landmark condition, images of the target landmarks and the text next waypoint were shown alongside the screen-fixed directional information. In the third word fixed with landmark condition, when a turn were required at decision point, a word fixed arrow cue is shown perpendicularly to the ground to ensure visibility and saliency. In the fourth word fixed with landmark condition, target landmarks were highlighted by a word fixed virtual circle with the text next waypoint. The augmented circle was registered onto the landmarks with 6 degrees of freedom, allowing for unobstructed viewing even in cases of occlusion. Two different predefined routes were used in our experiment. Each has similar length with 7 target landmarks alongside. 81 participants were recruited and randomly assigned to one of the 4 conditions and performed the task on one of the 2 routes. In the experiment, each participant was trained for locomotion first and then completed 7 tasks in the following order: 3 acceleration tasks, 3 pointing tasks, and a map drawing task at the end of 3 trials. In the acceleration, participants were asked to follow the air navigation cues in the assigned condition to get to the destination. They were shown images of 7 target landmarks prior to the task and asked to remember the position of these landmarks as best as they could during the navigation. Following each acceleration, participants were asked to complete a pointing task in which they were randomly transported to one of the 7 target landmarks and asked to point to other landmarks relative to their current position and heading without locomotion. Pointing arrows along the exit plane were recorded. In the map drawing task, participants were given a board textured with the route layout in the acceleration task and the images of the 7 target landmarks. They were instructed to place the target landmarks to the position that they believed the landmarks were located. We measured the similarity between the estimated map and the actual map by bidimensional regression coefficient R² with the affine and Euclidean transformation. After that, participants completed the SPSOD questionnaire. We conducted a factorial analysis of variance. The results show 3 main effects in the pointing test. First, people learn the spatial layout of an environment over trials when they are aided by AR cues. Second, pointing error for route 1 was greater than for route 2. Third, as self-reported abilities increased, angular pointing error decreased. There was also a significant frame of reference by type of information interaction. Pairwise comparisons found that pointing errors were significantly lower in the word-fixed design, but only when there are no landmark cues. The two-way interaction is qualified by a significant three-way interaction. The trend of pointing performance in each condition holds up in the first 2 trials, but training can reduce that interaction effect as performance becomes better. There are also marginal interactions. Feel free to read our paper to know more details. In the map drawing task, likely because performance was overall very high, there was only a significant mean effect of the SPSOD score for both Euclidean and affine R², which is significantly correlated with the SPSOD score. I conclude the findings from this study over here. When rendering AR cues in next-generation air navigation systems, the frame of reference of display information and the types of information should be considered together. Our findings indicate that word-fixed directional cues enhanced spatial knowledge acquisition when no landmarks were cued. Screen-fixed arrow cues alone are not a good way to display directions for pedestrians when considering spatial learning. Adding landmark information as cues to the screen might be one helpful low-cost solution. The results also suggest the needs on investigation of more effective way to anchor word-fixed landmark cues according to users' navigation abilities and strategies. In future work, evaluation of the air navigation systems in the field is needed to validate the findings in the simulated virtual environment and gain user feedback for using AR cues in variable real-world environment. Besides, more subjective feedbacks and body-based measures such as eye and hand movement could be included in future work to give specific insights into the strategies that people used with the cues. For now, thank you to listen to my presentation. I look forward to your questions.